Hello everyone, I'm Yuhui Wang, a master's student from Tohoku University. Today I'm here to present my paper, VirtuEleDent, a compact XR tooth cutting training system using a physical EMR-based dental handpiece and teeth model. First, about our research background. Dental cutting techniques are the foundation of restorative dentistry and treatment. Precise handling is directly related to treatment results and patient comfort, and therefore requires repeated training to ensure safety and effectiveness. However, the dental cutting training systems used in dental school are mostly expensive and large, and also consume a tooth model for each cutting. So, the environment, time, and frequency of training are limited. To support more affordable educational opportunities, XR training systems have been researched and developed to permit dental training in VR and AR. There are 3 related works here, and all of them use the 3D system touch haptic device to get haptic feedback. These types training systems do not consume teeth models and provide educational feedback. But the maximum reaction force of an active haptic device is limited, and it's still high cost and low probability. So we propose the VirtuEleDent, an XR tooth cutting training system with EMR stylus technology to solve these issues. Our goals are compact, low cost, present realistic visual and haptic sensations, be an initial prototype supporting major tooth cutting procedures. To achieve our goals, we attempt a new XR approach, a mix of physical and virtual elements through passive haptic feedback using physical props and a precise 3D tracking system. Our system is compact that only needs the HMD, a computer, and the EMR-based handpiece and the digitizer. Here is our tangible instruments. Our tracking system is built upon the EMR stylus technology by reusing the system of an actual product, the digitizer. The EMR stylus enable high-precision sensing and touch interaction, including 6-stop tracking, pressure sensing, vibration feedback, trackable up to 2.5 cm high from the digitizer. We evaluated the horizontal and vertical accuracy of our tracking system. About the horizontal direction, the mean absolute error in the stylus vertical state at a height of 0.5 mm is 0.11 mm, and at a height of 5.5 mm is 0.32 mm. About the vertical direction, we tested 3 posture conditions: fully vertical, D-angle dependency, and T-angle dependency. As shown, the error increases as the D-angle and T-angle increase. Next, I will introduce our training application. Occlusal surface cutting and lateral surface cutting are 2 typical cutting tasks given in local dentist license examinations. So our system implemented these 2 types of cutting. Because of the pressure sensor is at the tip of the burr, so the detection method of contact and cut areas are different between the 2 types of cutting. About the occlusal surface, the contact is based on the pressure sensor data, and the cut area is based on the burr tip's positional information. About the lateral surface, the contact is based on use the positional information of the burr to calculate the distance between the burr and the tooth. The cut area is based on use the unity raycast function to pinpoint the cutting area. The cut area can be visualized as shown in the bottom right-hand picture. For more accurate visualization, we have implemented a repositioning function. It's a function to fix height position of the burr tip. The tip contact to the teeth model in real world. Then this function can find the closest tooth surface mesh point and move the burr tip to the same height as the mesh point. So next I will show a demonstration video of our system.
Carious areas to be cut are marked in red, while cut areas appear in blue. Cutting begins when you press the digitizer's button, and the handpiece will start to vibrate during the cutting process. The completion shows the amount of the red area you've cut. The pressure level shows if the pressure applied during cutting is appropriate.
To understand the current prototype's potential, acceptance, and improvements from an educator's perspective, we conducted an expert user study with experienced dental clinicians. We implemented a haptic device version as a baseline using Touch HID, which is often used in current XR dental training systems. We prepare a caries scenario task for each cutting types, and participants were asked to cut the caries area up to 90%. These are the results of our original questionnaire. The average values of proposed method are essentially equivalent to, or in some cases better than, those of Touch HID. This leads us to conclude that we have successfully develop a system that is more compact and cost-effective while maintaining performance equivalent to the existing standard under the thin tooth cutting scenarios. The interviews were conducted based on the original questionnaire. We pick up the key comment of our system here. Although there are still many shortcomings, we have focused on the two issues shown in blood red text: the handpiece shaking and the shortness of the burr length, and try to solve them. First, we update the handpiece device to solve the problem of the tip's length. Next, we modify the algorithm so that repositioning does not occur when the handpiece is on the side of the tooth to prevent the handpiece from shaking in the lateral surface cutting. Finally, due to there are some requests for zoom in and zoom out viewpoint functions, we moved all of the keys necessary for using the application to the MetaQuest controller to facilitate the user's own use of these functions. After the update, 5 experts were invited to an additional trial session, followed by interviews and discussions to evaluate our improved components. We pick up the key comment here. Overall, the system received a very good evaluation with regard to operability and visual. As can be seen from the comments of the reality section, a number of issues were raised. But compared to the previous system, the discussion turned to more practical directions. These are our system's limitation and future work. VirtuEleDent has the height and metal devices limitation due to the use of EMR technology, and depth limitation due to the use of physical props. However, there is still a lot can be done under this restriction, and we will update our system under expert opinion. These are the main contributions of our research. As a conclusion, VirtuEleDent is an initial prototype supporting major tooth cutting procedures. Users can physically manipulate a handpiece with dexterity on a teeth model while experiencing virtual tooth cutting in an HMD under high precision tracking. This unique style of manipulation allows users to feel a high realistic touch. Further functionality will need to be extended according to the training scenario. Thank you for your attention.